video 26 discussed how channel liners can be locked based on any edits involving the cross-section, edits involving the channel lining material, edits involving the length of the flow segments, such as the shallow concentrated flow segment being extended from 300 to over 380 feet. Now in video 27, we're going to examine some additional edits on these locked channel segments to get more precise peak flow results. Now let's go into P3D and notice that we're going to examine channel segment 5, which we have set up to be a trapezoidal 10 feet. We did that in the previous video. And we're going to look at channel segment 3 and confirm it. We want to put it back to the default of 20% slope, which doesn't apply to this roadside ditch. At 20% slope, look to the right. The time of concentration is over 8 minutes. The peak flow is 38.4 CFS. They're right over here. TC and peak flow, 8 and 38. Now, one way to examine the actual cross-section of a channel from the DTM itself is to draw a polyline and click on the profile icon, and then as you place your cursor in the channel section, you can see the slope. Here it's 3:1, 33%, and over here it's 1:1, 100% slope. Well, if we change channel segment 3 by clicking it over to that cross-section from the 20% grade 1 that it's currently at to US 68 roadside, which is that setting, you can add various percent slopes, various styles of cross-sections with the plus, and then we'll hit OK. Now, if we look to the right, the TC has changed to let's take a look at it, 7.636, and the peak flow's gone up to 39.369 CFS, because what happens with riprap is interesting. When you get a steeper cross-section, the congestion of the stone in the cross-section itself actually increases the shear force and can slow down the travel time. The permissible shear force, went to 6.9, and if we go back to 20%, it drops to 6.0. So in the case of riprap, a steeper cross-section increases the permissible shear force. One more thing to point out. The permissible shear force is dynamically calculated by the nature of the flow percent, velocity, and cross-section, as you can see, as we've confirmed. But for any given channel lining class, there is a set permissible shear stress that you can make determinate in terms of what's allowed, and not use the calculated permissible shear stress, but use the preset one under the hydro settings liner materials. If we look at class 3, it's preset to a 5 permissible shear stress, pounds per square foot. If we click that on, as you can see, it actually will work in this case, because the calculated is 4, so it's not going to change it. It's not going to change it. If the calculated or average shear stress was greater than 5, it would bump up to the next class, which would be 1A in that list. Now, let's look at one more example here. We have edited this ditch to remove shallow concentrated flow and set it as channel flow with some sheet flow feeding it. And it's one simple channel. And as you can see, it is right now calculated as class 2. We're using a 20% slope, a 20% cross slope on the channel. The channel slope itself is defined as 8.18% here. And if we switch this over to grass lining, just force it, we can study what it calculates out to. You can see here that the permissible is 1.658, but the average calculated is 1.779. It's not going to work. And if you did turn on use liner permissible shear stress, these both exceed 1, so it would automatically, it would need to bump up. Though I have it locked right now on grass, it would bump up to class 2. But I have it locked. I've changed it and locked it into grass, but it has failed ever so slightly. If we were to reduce this, unlock it, you can see it was locked. If we were to reduce this to, we'll keep it as grass, but reduce the slope to 10%. We have a 10% channel defined, V ditch. If we did that, in the case of grass, reducing the slope increases the wetted perimeter or the contact area of the flow of water and actually increases the permissible shear force. This will go up right here when I hit OK. It went up to 1.975 and it passes. So it's expensive to put in riprap. You can redesign your channel cross sections to obtain grass wherever possible as a design technique.